This example on the left, we're going to write an algebraic expression for. We have the tangent of the arcsine of x. Recall that the arcsine of a ratio is equal to an angle. And the tangent of an angle is going to equal a ratio. So we're looking at a ratio of two side lengths. The tangent of an angle is equal to the opposite side over the adjacent side of the right triangle. So let's take the arcsine of x. The arcsine of x would be a lot clearer if we had x over 1, if we made it a fraction. That's going to help us draw a picture. Now remember, it's just an angle. Arcsine of x is just an angle. I'm going to call that angle theta. So we're going to put theta right there. Recall that the sine function has a ratio of the opposite side over the hypotenuse. So x is the opposite side, 1 is the hypotenuse. And when we use Pythagorean theorem, a squared plus b squared equals c squared, we're going to get the square root of 1 minus x squared for the side length that is adjacent to angle theta. Now with all of that in mind, we have an opposite side now, we have an adjacent side, and the ratio for tangent, the tangent of theta, is going to equal x over the square root of 1 minus x squared. When we rationalize that denominator, we're going to get x times the square root of 1 minus x squared all over 1 minus x squared. So that's going to be our answer. That is equivalent, I'm going to write equivalent, to the unrationalized denominator of x over the square root of 1 minus x squared. Sometimes we're given something that looks a little bit easier because it doesn't have a fraction and it doesn't have a variable in the fraction. For instance, the arctangent of a ratio is equal to an angle, and we'll call that angle once again theta. Now, tangent ratio is opposite over the adjacent side. So we'll identify one angle as theta, and this theta, because we're dealing with numbers, numerical values 12 and 5, we can actually determine that theta is in quadrant 1. Reason being is because arctangent goes from negative pi over 2 to pi over 2 for its angles, which are the outputs. And when the ratio is positive, we're dealing with angles in quadrant 1. And the cosine of an angle is going to equal a ratio. So we'll come back to our triangle. The arctangent of 12 over 5 means that the opposite side is 12 and the adjacent side is 5. That's going to give us a hypotenuse of 13. You can do that by using Pythagorean theorem, or if you know your Pythagorean triples, 5, 12, 13 is a Pythagorean triple. So our ratio for cosine, remember that cosine has a ratio of adjacent over hypotenuse. So the adjacent side is 5, the hypotenuse is 13, and that's how we're going to get 5 over 13. So the one on the left, we resulted in an algebraic expression because we don't know the side length, that's just a variable. But on the right-hand side, we had simplify because there were no variables. We can actually simplify that expression to be 5 over 13. Now, one last problem. We pull this all together in this problem right here. We have the sine of the inverse cosine of square root of 2 over 2 plus the inverse sine of 4 over 5. So let's remember that this right here, the inverse cosine of square root of 2 over 2, is just an angle, right? And the angle that it's going to be is an angle that is between 0 and pi, with a positive ratio. We'll be in quadrant 1, and And the inverse cosine of square root of 2 over 2 is actually pi over 4. So this is just pi over 4. And the inverse sine of 4 over 5, we would have to draw a triangle. So I'm going to just call that theta for now. So what we have is the sine of pi over 4 plus theta. And this is our addition property or addition formula, addition identity, equals sine of pi over 4 cosine of theta plus the sine of theta times the cosine of pi over 4. Now the sine of pi over 4 and the cosine of pi over 4, we know those values. That's the square root of 2 over 2. And the cosine happens to be the same thing for pi over 4. However, for the cosine of theta, we're going to need to draw a triangle. Now the sine of theta, well, let's draw the triangle because then it's going to just boom, boom, boom. We're just going to put those values in and you'll see. So we've got the inverse sine of 4 over 5 is equal to theta. And remember, sine is opposite over hypotenuse. This is another Pythagorean triple, so it's going to make our adjacent side 3. Now we have a triangle with a reference angle of theta. And the cosine of theta is going to be 3 over 5. And the sine of theta is going to be 4 over 5. So we have the sine of pi over 4 times the cosine of theta, so that's the square root of 2 over 2 times 3 over 5, plus the sine of theta, which is 4 over 5, times the cosine of pi over 4. And that results in 3 times the square root of 2 over 10, plus 4 times the square root of 2 over 10, which is going to equal 7 times the square root of 2 over 10. If we write this all over one denominator, that maybe will help you see the 7 times the square root of 2 is our answer.